Magandang araw! I hope everyone who's watching this video is safe, healthy, and happy. I'd like also to greet you a Happy New Year. So, magpasalamat. Let us be grateful that we are able to survive 2020 and all of us are now ready to face 2021. So, this is my first video for the year, no? And the presentation is about naming ethers. So ethers are organic compounds having two alkyl or aryl groups bonded to an oxygen atom. So ethers are actually derivatives of alcohol. Remember, yung alcohol ay ROH. So if we replace hydrogen with the same R or another alkyl or aryl group, then we have ethers. So we have here examples of ethers. So how do we name ethers? So first, we discuss how to give common names of ethers. So how do we do that? We identify the alkyl or aryl groups bonded to the oxygen atom and then name them alphabetically, separated using the word and affixing rather the word ether in the end. So let us try to do that. So we identify this to be methyl, and this is the ethyl group. So we write them as ethyl, methyl, ether. The name is ethyl, methyl, ether because ethyl comes first before methyl. And then we identify this to be ethyl group. This is the normal propyl group. So we name this as ethyl, propyl, ether. And this one, so the two alkyl groups are, so we have a cyclopropyl, and then we have a methyl group. So this is named as cyclopropyl methyl ether. So sana na-observe nyo, nakikita nyo no, na separate words, no? Yung dalawang alkyl or aryl substituent and then the word ether. So we also have here, so 1, 2, 3, 4. So this, we have a butyl, and then we have a 1, 2, 3, 4, 5. So we have a butyl, 2-pentyl ether. And this one, we have a 1, 2, 3. So we have an isopropyl, and then we have a 1, 2, 3, 4, 5. We have a pentyl group. Bonding is at carbon number 3 of pentyl. So we have isopropyl 3-pentyl ether. And then we have the ethyl group, 1, 2, ethyl group. And then we have a 1, 2, 3, a propyl group with a methyl substituent at carbon number 2. So we have ethyl 2-methyl propyl ether. I hope you also recognize that this is isobutyl. So we can also call this as ethyl isobutyl ether. Now we also have symmetrical ethers where the R and R prime are identical. So we have dimethyl ether. A dimethyl ether is used as a propellant and as a refrigerant. Then we have a dicyclobutyl ether. And then an example of a diaryl ether, we have the diphenyl ether. Now, how do we name using the IUPAC? So, ito may susundin tayong procedure. So, the common alkoxy substituents are given names derived from their alkyl component. The shorter alkyl group becomes the alkoxy substituent, while the longer one becomes the alkane base name. The alkyl group on each side of the oxygen is numbered separately, where numbering priority is given to the carbon closest to the oxygen. The alkoxy side, which is shorter, has an oxy ending with its corresponding alkyl group. Now, we must also consider to prioritize the functional groups. If there are alcohols, hydrocarbons, and halides, alcohols have the highest priority. So we have here the names of the alkyl groups. I hope you still remember methyl, ethyl, and so on under tertiary butyl. And then the analogous alkoxy group, notice that there is oxygen here, no? So the methyl group becomes methoxy, the ethyl group becomes ethoxy. So this is the bonding site. No? So we have methoxy, ethoxy, propoxy, and so on. And this is, no, the phenyl group becomes phenoxy. So how do we name? So let's start here. So we compare the methyl group. So this is the methyl group, and this is 1, 2, the ethyl group. So obviously methyl is shorter, and therefore we take methoxy as the substituent and the ethyl group as the parent chain. So we call this methoxyethane. Notice that it is written as a one word as opposed to separate words in the common names. No? So the ethyl methyl ether, the common name ethyl methyl ether, is methoxyethane in IUPAC. So here we have, so 1, 2, 3, 4. So we mentioned this earlier. No? So this becomes now 2-butoxypentane because 4, so the butyl group has a shorter chain as when compared to pentyl group. So this is 2-butoxypentane. So branching is at carbon number 2 of the pentyl group. So earlier we have isopropyl 3-pentyl ether is now called 3-isopropoxypentane. So the isopropoxy group is considered to be the substituent and the pentane as the parent chain. Again, written as one word. Then we have ethoxy 2-methylpropane. This is propane, and also called ethoxy isobutane. And then we also have this 1, 2, 3. So we have a propane, but note that there are 2 methoxy group no on both ends. So we have a 1,3-dimethoxypropane. Here we have a 1, 2, 3, 4, 5. So we have a pentane, but there is an OH group. So this is considered to be as an alcohol or a pentanol. So numbering of carbon starts at the end near the OH group. So this is carbon number 1, 2, 3, 4. So bromo is attached to carbon number 4 and methoxy group is attached to carbon number 3. So we write them, we name the substituent using the alphabet. No? So bromo comes first. So we have 4 bromo, 3 methoxy, 2 pentanol. So notice the use of hyphen to separate numbers and letters. So we also have 2-methoxy 2-methylpropane. No? So O comes first before Y. So this is the propane group. So you have 1, 2, 3, and this methyl is considered to be a substituent at carbon number 2. The methoxy group, this whole thing is attached to carbon number 2. So we have 2-methoxy 2-methylpropane. And then we have a hexene. So 1, 2, 3, 4, 5, 6. No? And then we have an ethoxy group at carbon number 4 and a methyl group at carbon number 2. So we have 4-ethoxy 2-methyl 1-hexene. Okay? So again, E comes first before M. We have also here a methoxybenzene. This is shorter. So this is the alkoxy substituent. And then the benzene ring as the parent. So we have methoxybenzene, or commonly called anisole. And then we have a butanol, 1, 2, 3, 4, with substituent, an isopropoxy substituent at carbon number 3. So this is 3-isopropoxy 1-butanol. So here we have cyclohexane, with ethyl substituent and a phenoxy substituent, which are of the same side. So we have a cis configuration for ethyl and the phenoxy group. So this is cis 1-ethyl. So numbering starts here. So this is carbon number 1, 2, and 3, such that we have a cis 1-ethyl 3-phenoxycyclohexane. Now, how do we name cyclic ethers? Now, Ring compounds containing nitrogen, oxygen, sulfur, or other elements as ring atoms generally are known as heterocyclic compounds. And the ring atoms other than carbon are the hetero atoms. So, in any cyclic groups, carbon can be replaced by atoms rather, but specifically nitrogen, oxygen, and sulfur. Okay? So, if the carbon is replaced by oxygen, we call that oxa. If it is replaced by nitrogen, we call it aza. If it is replaced by sulfur, we call it thia. So, we have oxa, aza, and thia derivatives of cycloalkanes. We could also use dioxa, dithia, or diaza if there are two oxygen, sulfur, or nitrogen atoms respectively. So, here, notice that in the cyclohexane, carbon is replaced by oxygen in locants 1 and 4. So, this is now an oxa, cyclohexane, referring to the replacement of carbon by oxygen. So, we have a 1,4-dioxacyclohexane. This one is cyclopentane, but oxygen replaces carbon. So, we have an oxacyclopentane, 1-oxacyclopentane, or simply oxacyclopentane. Note that in these compounds, numbering starts at oxygen and continues around the ring. So, using the Ans-Wittmann nomenclature, Ans, we read this as Ans, so kasi German yung pangalan na to. So, ring size is denoted by the stem ear, et, all, in, ep, ok, on, or ek for 3 to 10 membered rings respectively. So, alam naman natin, ang simplest ring size ay yung 3. Hindi ka naman makakabuo kung less than 3, diba? Now, it is important that when 2 or more different heteroatoms are present, they are cited in order of preference. So, ano ba yung preference? Oxygen comes before sulfur. Sulfur comes before nitrogen. No? So, we have an oxaza, so oxygen tapos nitrogen, and a thiaza, sulfur, and then nitrogen. Okay? Now, the degree of unsaturation is specified in the suffix. So yung Ans-Wittmann, ito yung table niya. No? So, ayan yung mga ginagamit na pangalan sa unsaturated. Irene, et, ol, in, epine, oxine, onin, esine, from 3 to 10 ring size respectively. For saturated, we have irene, ethane, olane, ane, epane, octane, onane, and ecane respectively. So, you can always refer to this table if you want to use the Ans-Wittmann nomenclature. So, for example, yung oxacyclopropane can be called as oxyrane using the Ans-Wittmann. This is actually also called ethylene oxide when we go to epoxide. Wala pa naman tayo doon. So, the oxacyclopentane can be called as oxolane using the Ans-Wittmann, or commonly called tetrahydrofuran. The oxacyclohexane can be called as oxane or tetrahydropyran using the common name. Take note that carbon in all these cyclic compounds are replaced by oxygen. Thus, the oxa prefixes. So, we have here cyclopentadiene. We have a 1-oxa-2,4-cyclopentadiene. Oxygen is locant 1. And then we have 2, 3, 4. No? So, 2, 4, yung double bonds ay at carbon 2, 4. So, 1-oxa-2,4-cyclopentadiene or oxole. So, we have an oxaza, no? So, we have an oxygen and nitrogen. So, we have a 1,2-oxacycloheptatriene. Wala namang ibang paglalagyan ng double bond kung di doon lang din, kaya hindi na siya binabanggit. And then, finally, we have a cis 2,3-dimethyl oxacyclopropane. So, yung methyl group, same side. Pag opposite side, we have a trans 2,3-dimethyl oxacyclopropane. Okay? So, I hope malinaw ang pagpangalan ng ether. Salamat. Thank you for listening. Remember, no one is you, and that is your superpower. So, till next time, bye for now. You stay safe and you stay healthy, class. See you when I see you.